In today's video, we will explain the coding basics of C# and the coding basics of Unity functions itself. So to start with the most familiar one, which is the if statement. To understand it, we will study its visual flow and code example. Visual flow, it's like check, is it raining? Yes, do something. If no, do nothing. It's easy, right? Just like in English. In code, we first write if, open brackets, then do something. Here is the variable or the identification inside the if statement. Here is the if statement, here's its syntax. This is just a comment, don't mind it. Usually you will put another code here, but this is the basics of if statement. Let's say you want an intersected connection between multiple if statements and just one if statement or two or three are not enough. Here we will use a switch statement, and the visual flow of this is like button, press. It could be either of these. One, press, two, press. Let's say press 1 give you chips, press 2 give you chocolate, and the third press give you a soda. This is how the switch statement looks in logic or a visual flow of it. In code, it looked like case 1, blah blah blah, break, which means go and check case 2, blah blah blah, break until you reach default, also blah blah blah, then break. Blah 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 is, by the way, just a code that you do or use. For example, adding force to a game object to make it move. For example, now let's go to loops. A visual flow of one of the most well-known loops, our while loop, is are there any cookies? If yes, take a cookie, then check again. So we get back to this point. If no, done. This is a simple logic explanation of a visual flow of a while loop. The code example is while blah blah is larger than 0, whatever this is, do something, then the blah blah is minus minus, then this might be a variable, an int variable like a cookie, which is equal to 3. So 3 times is done, we will close this while loop. A for loop, similar, but it would be in a diagonal way, like step 1, step 2, multiple steps, then like 10, then, so it's the same but like diagonal, just like this. So an if statement is one condition to check, a switch statement is multiple specific choices for one thing, loops are usually repeat an action multiple times. What about variables, the blah 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 we were talking about? We have an int variable, which is a number coming from the integer, a string, which is a name, example, hero, or a player, an enemy. Float is a speed usually, or a value that could be identified with decimals, sometimes like 5.5 and stuff like that. We have functions. Void. Functions are called void in C#. Heal, for example. It's similar to the syntax of the if statement, if you note that. But now talking about some Unity specific functions, we have the start method, which runs once at the beginning of the object when it becomes active or the first frame of the scene. Also awake is before the first scene, so you could use that too. We have an update method. These are all done from Unity, so they are not in casual C#. Update method is running the code every frame, so it runs 60 times per second if it's 60 FPS, depending on the frame rate. We have Gizmos, which is a visual tool in the scene view, does not happen in game, where you can draw things like draw the range of attack of an enemy, or the range of detection, or the angle of vision, or maybe the ground check of the player. So these are the gizmos, which you called by on draw gizmos, specify the color, gizmos.color, then gizmos draw wire or a cell wire sphere or a box or anything, any shape you want. Also, Unity gave us quarantine. Quarantines are special functions that run over time, not instantly. For example, set a timer. Instead of doing everything at once, you wait before the next. It's written like I am traitor, wait, and shot, for example. function. We do like yield, return, wait for second, and maybe wait 1 second. Seconds are floating points. And then a code, debug.log, shoot after 2 seconds, for example. Also, when you call a function, you call it like this, like heal. But when you call a quarantine, you call it saying start quarantine, open a brackets, write quarantine function like wait and shoot, then open 2 brackets, then close the brackets of start quarantine. So it's like this, and then you are calling a quarantine function, not a normal. So a variable is something that stores data. It's more like a labeled box. Use cases is like player health, score, and speed. A functions is like doing something. For example, an analogy of it is a recipe. It's like healing a player, moving a character. The start method runs once, usually used for initializing values. An update runs every frame, usually used for player input, camera follow, and specialized functions. Gizmos is for drawing ranges in scene. Quarantine, wait and do later, like setting up a timer. Use cases are delays and step-by-step action. Other Unity functions are on enabled and on disabled. This runs when the object is activated, and this runs when the object is deactivated, like turning on a light switch and then turning it off. You have fixed update, which is usually used for physics in Unity. Late update, usually used to run an action after the update method. We have on collision enter and on trigger enter. In Unity there is collisions either be normal or trigger, which cannot be only done by code. When you specify the trigger function, they won't affect other objects, only if you put a code like on trigger enter. If he enters his trigger, you could use it like a range or something like that. Do something. We have on collision enter. If he entered the collision of an object or touched it, something like that happened, like dealing a damage or something like that. We have instantiate, which generates an object, so creates a new object, usually used for particle system and spawning systems and stuff like that. You have also a destroy function with multiple choices. You can destroy after a time, you can destroy after a function, you can destroy a child object, you can destroy the parent only, and you can destroy even a component, so it has many stuff. All of these have multiple more info, but we are taking the tiptoes here just so you understand everything, and if you already understand code, you are revising every information you've ever taken. We have input get key, and this is to reading the input from the keyboard and doing an action when you read this input, or maybe get a button, just a key, or using a controller. We have time.delta time, which we said we will explain its complications later, but it's like a stopwatch measuring tiny time steps. Usually it's time since last frame usually set. So yeah. We have invoke for delays without quarantines. Call a function, for example, after a delay, like setting up a reminder. We have also player prefs, which is storing data in Unity, keeping scores, or like updating the weapons when you transition from one scene to scene. They stay in your inventory and stuff like that. More we have get components, which gets a component of the components inside the object, because he might have like a rigid body, a collider, and a script. So you get the component by calling the function get component with these parentheses. You can get component in children, you can get component in parents, you can find a game object, not usually used, but it's a function that is found in Unity, which finds any game object by name in the scene. You have find with tag, which finds a game object with the tag, like enemy, for example, inside Unity or inside the scene that's running in Unity. We have find game object with tag, and this is expensive, by the way. On the CPU, every function could be expensive, like the update method or these. So we will talk about optimizing code later, but this is an example for finding and getting component of a game object. So find game object with tag finds all game objects with a tag of the find with tag, the first game object with a specific tag. We have the transform. You can take the transform, aka the position of an object or its parent or its child count. For example, you can know the number of children that transform if you want to calculate something inside like a small inventory hierarchy and found in the child's. So yeah, multiple case scenarios, but you can use transform. You can also transform.parent to access the parent if the code was in children. Some basic stuff, but people usually forget it. What is a class? Class is a blueprint for creating objects, grouping variables and functions. Usually it's a mono behavior class in Unity, and it's something like a public class or player health class or a health class, for example, or something like that. We have a static. A static belongs to the class, not any object instance. A rulebook shared by everyone, not by individual people. A protect is the access level visible to this class and derived classes only. So a private family recipe, for example, only the family can use. And lastly, something everybody forgets for some reason, which are enums, listed of named variable, like a menu with the preset choices like easy, medium, hard. You can like use it for difficulty, like easy or medium or something like that. Some people use it for states or types, like a weapon type, something like. You might be overwhelmed, but this is not like a very beginner friendly course. It's for like intermediate to advanced course. I'm revising every information or every code case we usually use in Unity. There's multiple cases, of course, and multiple types of, but we are trying to revise everything before starting in more complicated stuff, to revise every condition like if and switch, every loops like for while and for each, every classes, static, protected, enums, the specialized Unity functions like start, update, quarantines, gizmos, get component, finding game object with tags, instantiating or destroying. We are trying to revise everything we could learn from Unity and coding in Unity to start in really how to like build complicated algorithms and build an industry standard assets and systems for your game. So you need to understand all of these. You can use this episode always to revise your information about everything we explain. Thanks for watching and see you in the next video.